No. No, but I can do that for you if you'd like.
I like that.
Yeah?
It's too much work.
It's not too much work if it's going to help you. And then we don't have to spend time in class going through them. Yeah. Okay, so convert 113 degrees to radians. So how do we convert a degree to a radian? What do we multiply by? Pi, we want radians, so pi on top over 180 degrees. If I want this as an exact value, what do I type in my calculator? 113 divided by 180, and then I go math. There you go. I don't think this will reduce, will it? Let's delete. Math, enter, enter. No, it doesn't reduce. If I wanted a decimal, I just type in times pi over 180. And so 1.972. Right, that's converting? Maybe not. It could show up though on your diploma. Convert 5.2 radians to degrees. So what do we multiply if I want to change it to a degree? 180 over pi. So we have 5.24 times 180 divided by pi. 300.2 degrees. Okay, it's pretty basic. So one of the big portions of this unit was understanding the equation of the line. So it says determine the range, amplitude, period, and equation of the midline for the following. So let's start with, in order to get the range, what do you have to know? The range is always between what two values of y, right? So if you have a sinusoidal, what would I need to know the range? The max and the min. Okay, so how do I get the maximum from my equation? What equation did we use to get our max? D plus A. So start at our midline, add the amplitude. So our midline would be -2 plus 2 would give me, nope, 0. Min would be D minus A. Start our midline, take away my amplitude. So -2 minus 2, -4. -4. Okay. So then, therefore, what's the range of this function? Y is greater than -4 or equal to, and less than or equal to 0. So that's the first part. Amplitude. What would be the amplitude of this guy? What's the amplitude? Yellow? Is that how you guys feel? You're so quiet. Yeah, you know. Never mind. The amplitude's yellow. No, what is it? 2. It's yellow. Okay, our A value is our amplitude of 2. It's also the radius if it's an application question. Okay, how do we get the period of our function? What's the formula? It's on your formula sheet. 2 pi over b. What's my b value here? Number in front of x. 1. So 2 pi divided by 1 just gives you 2 pi. And then the equation of the midline, what would be the equation of the midline? Spencer? Do you know? Which one's our midline? Of all this data here. It's -2. So as an equation, it'd be y equals -2. This would probably be either a regression equation or an application question like this next example. Hooray! Yippee-ki-yay. I actually boards the Ferris wheel at the Pacific National Exhibition, actually. When the ride begins, her position can be modeled by the following function. Now, if I were you and I got to my exam, what's probably the first thing you're going to do? Before you freak out, graph it. Okay, so let's grab our calculators. They gave us equation, let's graph it. Now, do I want my plots on or off? Off. They're just going to cause havoc. Otherwise, we're not using a regression equation. Turn them off. 43 sine. Sine. Now, automatically when you push sine, it opens up a bracket. So then you're going to have to go 3.5, another bracket, x minus 0.9, and then close both brackets, plus 47. What mode should our calculator be in? Radian. Do we have to change that? No, it's automatically in radian. How could I get my window settings? Let's talk about the y value. So 47 is our midline. To get our max, we add our amplitude. So it's going to go up to 90 maximum. So we can go up to 100, and then 47 minus 43, almost 0. So we want to go from 0 to 100 for our y value. Okay, 0 for y. And we'll go a scale of 10. Now, this is our b value, 3.5. Remember, the period is 2 pi divided by b. So if you wanted to see one full rotation, you could go 2 pi divided by 3.5. So about 1.7. Now, maybe if I wanted to make 2 rotations, instead of going from 0 to 2, I could go 0 to 4. Scale of 0.5 maybe. So I figured out my period by going 2 pi divided by b, and I basically doubled it so I can see 2 full rotations when we graph it. Yeah, you could try zoom trig. There's a zoom trig button. You try that. But now I know this is going to be a perfect window setting. Look how beautiful that is. I don't think you can get better. It's just so nice. Okay, so now we've done that. We've graphed it. We're talking about a Ferris wheel. So we can see that you're getting off a little bit off the ground, right? And then you're riding up and down. Determine the diameter of the Ferris wheel. So what is going to be the diameter equal to? How do we get diameter? Twice the radius. 2 times your radius. And which one of these is the radius? The amplitude is radius. So 2 times my radius is actually 43. So 86 feet. Okay. How long does it take the Ferris wheel to come to complete 1 revolution? So what are they really asking for? Period. That's really asking for what is the period. And we get the period by which formula? What's the formula for period? 2 pi over b. So in this case, 2 pi over, what's my b value? 3.5. And we already calculated this when we did our windows. It's like 1.7, I think. 2 pi over 3.5. 1.8, 1.795. And that's in what? What unit would that be? Seconds, hours, minutes, minutes. And then last it says, how high above the ground is Ashley at the lowest point? Yes. If it's a numerical response, they will tell you. If it's a multiple choice, you can figure it out. But they'll also tell you. They will tell you, always. These questions have been looked over like 100 times. So, yeah, they will tell you. How high above the ground is Ashley at the lowest point? So what are we really looking for? What is the lowest point? What do we call that? The min. And what formula do we use to get min? D minus A. We started our midline, subtract our amplitude. So our D is 47 minus 43 is 4 feet off the ground. All right. Is there another regression? No. This is it, right? One more, and we're done. Okay, we're gonna do it. Why? Why not? 72 numbers times 2. No, just 72. Yeah, that's not bad. Okay, so we have a regression equation to type in. We should have a race. I lose right off the bat. So the easiest way is just spend your time clicking numbers. Oh, 6, 36. 1 to 36. 13, 14, 15, 16, 17, 18, 19, 20. It gives your fingers a workout, which is nice. I want that carpal tunnel. This is the easy part. We haven't got to the hard part yet. 36. Okay. Oh. Okay, good. Okay. So now comes the fun part. But it's really nice if someone reads it to you. 3.5, 2.4, 1.8, 1.9. It's going to be a really nice regression, I think. 2.7. Now, what did I always say about regression equations when you're writing a diploma? I like to say this a lot. Oh. Turn your plots on, yep. 10. Make sure you go through your list after and you typed it all in properly, because that would be tragic. Literally tragic. I hope that doesn't happen to anyone here. We're skipping. Injured. 24, 5.9. I almost threw myself off there. 4.6, 3.2, 2.1. Whew, almost done. Is anyone done? You guys are all probably done already, hey? 5.4, 6.5. Thank you. That's why it's nice having other eyes. No, I promise you they won't. Yeah, is it? Is it really though? Whew. Gotta stretch my fingers now. Typing. Okay, so what are we gonna do next? When they give you all this data, stat. We need to go. Now, does it say what type of regression we're gonna do? No, we have to actually. So we can't. Oh, that, and then it goes on and says sinusoidal. So now we do know. So stat. Or you can go, as long as your stat plot's on, they might not tell you. They might just, if you go zoom 9, you should be able to figure out, okay, what does it have to be? Well, linear, no, right? Right, so they might not tell you, but if you actually graph it, you'll see. It'll be obvious to you, okay? So stat, calc, sinusoidal is C. And then vars, y vars, enter, enter. Now make sure you go black, don't go black. And no, I came out wrong. Okay, don't go back. And just moving on. Don't.
Are we recording this?
I'm gonna edit this video. Where am I at? 12:43. Okay, edit that portion out. So don't go. You make sure you go back and turn your plots on, right? Else you're not gonna see anything. So Ferris, I didn't mean that. Okay. Did it ruin mine? No, I'm just kidding. Oh. Sometimes, hey? Sometimes. All right, so does the regression does it match nicely? Let's take a look at our graph. It's all flustered now. Okay, does it nicely match, or does our regression nicely match our data? Yeah, like almost all of them are going right through it. You see the ones that aren't, but most of them are going through it. It is a nice regression equation. Okay, so the equation is what? So let's write that down. I cheat. That's helpful, you know? Instead of going back and forth. Sorry, a little loud. Okay, so y equals 2.7, let's go 2 decimal places, 3, sine 0.51 x plus 3.02 plus 4.4. Okay, it says how high is the water at high tide? So what is it really asking for? Max. Now, there's 2 ways we can get our max. What's one way we can get our max? B plus A. So that would be 4.4 plus 2.73. So adding the exact values. So I would actually go back and add the exact values that I see. So 4.4, 26, 100, 141 plus my A, 269, 12887. Okay, and so there it is. It says how many decimal places? 2 or 1? And 10 has 1 0. 10 is 1 0. So 1 decimal place. 7.2 meters. Okay, the other way, what's the other way you can get your maximum? Graph, second trace, 4. And then you have to go like pick one of the maximums. So left of it, enter. Go right of it, enter, and then make a guess. And it'll tell you what it is. 7.2. Okay. It says how high is it at low tide? So what is it looking for there? Min. How do we get min? D minus A. So the nice thing about doing this is I could just grab my calculator, quit out of here, go second enter, just change our sign to a minus now. 1.7. That was easy. Where's my easy button? How long to the nearest minute does it take for the tide to cycle from high tide to low tide and back again? So what is it really looking for?
Hi, Jesse.
High tide to low tide and back again. Period. So it's looking for the period. How do we get period? 2 pi over our b. And what's my b value? 0.51. So grabbing this. You might have to go back to your regression equation so you can see what your b value is. Thinking. It was a lot of data I had to regress. Okay, so 2 pi divided by my b value, in this case is 0.5. We want to use our exact values always, not your rounded answers. It's kind of like tacky to do that. It's not going to give you an accurate answer if you use your rounded. Usually, yes, they're good. Yeah, I've seen that. Yeah, so use your exact values.
So if you like would mess up
I'm guessing probably not, but I have seen it before. So I don't ever rule that out. Okay, so 12, and usually it's to the nearest minute so that it wouldn't matter, right? But this one says to the nearest minute would be 12. So if you didn't use your exact, you would have got the same, right? That's all. Simon plans to go fishing at hour 50. Uh-oh. Uh-oh. Wait a second. This was in hours, guys. Sorry, let's go back here. So this was 12.41 hours, and it says to the nearest minute. So what do we have to do with this 0.4? It wants it in minutes. So you could either just take this whole thing and times it by 60 to get total number of minutes. So times it by 60 would be 745 minutes total. There you go. Careful of that. Okay, so now they give us at hour 50. Is that our X or our Y? Let's see. Yep, it's X. So X equals 50. So going to our graph. I don't think we went as far as 50. So Windows, our X is, oh, okay, so we can change that. So it's 52, sure. Also, it's just going to give us an error, so it's good to check those things. Okay, so now how do we get it? X equals 50. Second trace 1, 50, and enter is 4.3 meters. All right. We have some time today, so I think we should go with the usual 20 minutes, and then I'll go over the practice test for sinusoidal. Okay? So get started on that, and then we'll go over it. A typical wind turbine has blades that are 30 meters long. So right away, that tells you basically if this is moving in a circular motion, right? Something like that. Our radius would be 30. No, we just went through it. It was C. Okay. Okay. So it says determine the amplitude and max. Remember, guys, a lot of rude talking going on. Okay, so amplitude is equal to the radius, right? So our radius of this guy is 30, so the amplitude should be 30. So we know it's not going to be C or D. The max value we're going to get, D plus the radius. So we have 80 plus the 30 is 110. So that would be B. Okay? This is A, this is B. There's no C or D in this equation. Amplitude would be 3, so you know it's between A and D. Okay, because the amplitude is 3, which is our A value. Midline would be 0. Those are both the same, so we need to figure out the period. If B is equal to 2 pi over my period, then what's period equal to? 2 pi over B. And 2 pi divided by 0.5, or a half, is 4 pi. 2 over a half is 4. So this is the formula you need to know for period equals 2 pi over B. B is the number in front of X. The 1/2, yeah. Okay. Use the following answer. be very careful of this, right? Always read that top portion. We have a tendency to skip it. And often they'll do that. They'll have questions that will have like maybe 3 parts. So you want to see, okay, this has to do with the next 2 questions. The height of a Ferris wheel can be modeled by the following. According to the sinusoidal regression, the maximum height. So we need to use max equals d plus a. Our d is what? 8 plus our a value is 6, which gives us b. Okay, you need to graph this one to answer the next question. So our equation, I'm going to turn my plots off. 6 sine 1.05x minus 1.57 plus 8. And you might want to try zoom trig. Sometimes that works really good. Zoom 7. Sometimes it doesn't. Okay, this time it didn't. So we'll change our windows. We know our maximum's 14. So y should be at least up to 14. Let's try that. There we go. That's pretty good. I probably don't need the negative portion. We could start at 0, right? Because it's an application problem. You can't have negative time. So the question asks, when the rider is at least 11.5 meters above the ground, the first thing you need to know is this is the height or the y value. This is a y value. So if I want to find out when is he reaching first 11.5, so we want to find out, this question is asking how long is he above 11.5 meters. So your first step is you're going to have to go to y2 and go 11.5 and then graph it. So we really want this time in here. How long is this? We're above 11.5 meters. Well, find the 2 intersections and then subtract them. So second, trace 5. Go to the first guy. 1, 2, 3. So 2.09 minutes to find our other one. Go over. Takes a moment. Okay, close enough. And 3.89. So subtracting these two, we get 1.8. And it says to the nearest tenth, right? 1.8. Can't have a negative. Okay. All right. So when you see a table, most likely, what are we doing? Stat edit. Entering it into our calc. Alrighty. Clear. Clear. 0.24. Did anyone have troubles with this question? Yeah? We don't just skip it. 108, 122, 86, 107, 123, 86, and 108.6. Okay, so stat, calc, sinusoidal is the last one. Vars, y vars, enter, enter. Very repetitive. Feel like a broken record. Okay, so where would we get our highest, if you go zoom 9, where would be our highest blood pressure? How do you find that? Max, and max is C plus A, or you can use your calculator. Ooh, that's not nice. What's wrong with this? Why wasn't it giving me a nice graph? Lots are off. So now try zoom 9. It should, yeah, I guess so. It's not going to bother me because it's way below our data.
Did you change your windows or did you use
I did zoom 9. assume 9. Yeah. Okay, so the maximum, you can also get max by second trace 4. Your calculator can do a lot of this stuff for you if you don't want to go D plus A. Just have to know how to use it. Okay, did you get 126? Okay. What did you get for the minimum blood pressure? I could do D minus A. So instead of using the graph, you could take your D value, 1747, subtract your A value. Close enough. So 83.9. Okay. So after collecting the data, plotting, and finding the regression equation, Matt decides to research blood pressure on the internet. He learns that systolic refers to the highest point of blood pressure, and diastolic refers to the lowest point. So what category does Matt fit into? So his highest is 126. So he is he less than 120? No. He's 126. So he would be less than 130. Okay, and he's less than 85. So he would be normal. Yay. That's a good thing. That's a cool question. I like that one too. That's a fun, right? So that's an example of an application type problem. It wasn't so bad. So just because it's application doesn't mean it's scary.
What's conceptual?
Conceptual, like theory. So like, if I took a sinusoidal graph and we shifted it upwards and we increased the period, what would be the graph? So it'd probably be like, yeah, taking your knowledge and applying it to like a theoretic situation. Okay. 1893. I don't know if I'd actually want to get on this Ferris wheel. Columbian Exposition Ferris wheel. Giant. So another application problem. It says the wheel rivaled the Eiffel Tower, the centerpiece of the 1889 Paris Exposition. The famous wheel stood 264 feet tall. That might be important later on. Held 36 gondolas. Probably not that important. Could be gondolas. Thank you. Gondolas. Okay. And was powered by steam engines. It took a mind-boggling 20 minutes for the wheel to make 2 revolutions. I don't know. Okay, so that means, what's my period of this function? It takes 20 minutes to do 2 revolutions. The period would actually be 10. 10 minutes. Okay. If the minimum height of the gondola of the Ferris wheel is 2 feet off the ground, minimum is 2 feet, what would be a possible equation representing the function? Okay, so first off, we know our min is 2. Okay, how can I get my maximum height? 264 plus the 2. So if it's 264 feet tall, I'm guessing this is including the 2 feet off the ground, though. Yeah, right? So that would be my max. Because if they're going to measure, they're going to say, how high am I? They don't. Yeah, well, okay. So from this, what's the formula for amplitude? Max plus min. Is it max plus min divided by 2 or max minus? Max minus min divided by 2. So 264 minus 2 over 2. 262 divided by 2, 131. So our amplitude's 131. So right away, who can we cross off? Just D, based on the amplitude. Okay. What's my midline going to be? How do we get my midline? Which formula? Very similar to this guy. What's the difference? Plus. You're averaging, right? So max plus min over 2. So 264 plus 2 over 2. 266 is 133. Okay, so C is gone. Only thing left out to figure out is our B. Yeah. What's the formula for B? We figured out B first. Probably just do that. Right? So you knew the difference? So to figure out your which one equals 10. Yeah, you could do that. So 2 pi over your period, or you could do 2 pi over B. Okay, your period should be 10. So here, 2 pi over 10 equals 0.628. So that would be my B value. So the answer is B. Okay. We're done. I don't know if you guys finished your logs and polynomials practice stuff. So maybe we'll go over those two tomorrow. You have the rest of class to work on whatever you review. You might want to start this practice final exam. Okay, or some of those questions. Remember, there's old practice tests. Really, you're not lacking in resources. 1 second.